Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. So guys, in the previous video we have talked about what is linked list and how exactly it works internally. Means we have created one node and we have implemented our own link. So today we are going to cover about different methods available in linked list because these are the basic questions people might ask you at the time of interview, and if you really want to use in your project also. And if you are using linked list, these are the different methods. Very simple topic, guys, we are going to cover. So let me create a class over here, and I'm going to create a simple class that is linked list methods. Select the main method and click on finish. Now in this particular class, I'm going to write a couple of documentation for you guys, couple of important notes, so that you will understand that linked list is a default class which is already available in Java. So I would write it is a default class in Java. Okay, so you don't need to implement linked list all the time. That is for interview point of view and for understanding point of view that how exactly linked list works internally, right? And as I told you that along with list interface, it implements a queue and dequeue also. So remember this thing that it can be used as list. You can use it with the for a stack, and you can use it with the queue also, as it implements all these interfaces. So this is the advantage of linked list as compared to array list, because it's having the feature of list as well as a stack and queue. Now, what about null entry? Yes, it allows the null entry. We can have it. Okay, we can have null values over there. And is it static or dynamic? Of course, it is a dynamic collection. Okay, it allocates memory whenever it's required. Therefore, insertion and deletion operations can be easily implemented. So yes, dynamic collection. Hence, I will write a basic note over here that insertion and deletion can be, I would write easily. What about duplicate elements? Yes, it can contain duplicate elements. So if it's right, it can contain duplicate elements. And what about a synchronization? This is not at all synchronized. So it is not synchronized or thread safe. Okay, I would say not thread safe. It means multiple threads can do the read and write operation at the same time. So that's why this is not a thread safe. Okay. Now I'm pretty much sure that okay, after watching the entire series of the collection, you guys are very much comfortable with these terms like what is thread safe, synchronized, non-synchronized, null entries, dynamic collections, and all those things. Okay. And the last point is, remember guys, at a time of interview, you have to tell that okay, in linked list, I would write that manipulation. Manipulation is fast as compared to arrays. Okay, because we don't need any shifting, right guys? Because it contains a pointer value which is pointing to the next node, right? So that's why guys, we don't need any kind of shifting. So if you take a typical linked list, let's see, this is as in the previous example we have seen that we have data, and this is the next pointer, next node having the data, next pointer, next node having the data, and the next pointer over here. So this next pointer is actually connected to this data. This next node is connected to the third node data. So the shifting is very easy. We don't need to do manipulation, and we don't need to do any kind of shifting over here. I want to introduce one more node. I simple between these two guys. I break the connection from here. Next point will point to start this guy, and the next is start pointing to this guy. That's it. But in case of arrays, let's see, this is a typical static array that I have it. In this particular static array, the values are already available. Let's see, some values are already available over here. And a new value that I want to store over here, I have to do a shifting over here. This entire array from this particular position to n number of position have to shift towards this side, and then this particular value will be added over here like that. So that's where these kind of operations are very expensive as compared to linked list. So in this case, I would always prefer linked list instead of a typical static array. Okay, so these are the different basic notes about linked list, guys. And now there are various methods are available. There are multiple methods are available. But before that, there are linked list, talk about constructor. What are the different constructors are available? So I simple write linked list constructor. There are two basic constructor. One is a typical linked list constructor, which is a default constructor. Second linked list constructor is you can create with collection, with the existing collections. These are the two constructors are available, guys, that I'll show you. Now, these are the various methods. I have already collected a list from the Java documentation of the JDK, and see there are various methods are available: add method, and then add all method, and add first, clear, cloning, element, get method, index of, last index of, iterator methods are available, remove method, polling methods are available. So we are not going to cover size method is available, set method, and then all these things. So we are not going to cover each and every method because it will take a lot of time, and each and every method is not that important. You can, if you really want to use it, you can check it by your own later, but we are going to cover some important one and some basic ones. So let's talk about it. So how to declare one linked list? So let's create one linked list over here. That is, linked list is the class. We need to create the object of linked list, and let's say I want to create a linked list with the string values. So as a generics, I have to give a string over here. Let's see ll, or let's see these are my names list is equal to new linked list, and put a bracket and a string over here. Okay, and then import this particular linked list from java.util package. See, java.util package, we have to import that. Okay, now from this particular names, I'm going to add, there is a add method, add, and what kind of values I can store? Let's say I'm going to add a simple value, that is, let's say Tom, right? Okay, so one value got added, and in this particular node, our node will be created. In this particular node, Tom will be added, and this node is pointing to null. The next pointer is pointing to null. So remember, whenever I'm writing this particular line at line number 23, initializing my linked list, and immediately I want to check that, okay, hey, what is the size of this particular list? So I simply write names dot size. So if you run it, let's see what is the size. So run as a Java application, it's saying 0, right guys? It's saying 0 over here because right now we don't have any element. My physical capacity of this particular linked list is 0. But now I'm going to add one value over here and one more value. Let's say I'm going to add Tom, and I'm going to add Naveen, and then I'm going to check the size once again. So it will give you 2 over here, and let's run it and let's see. So you can see 2 got added, right? And then I'm running in debug mode, and I'll show you one interesting thing over here. Put a debugger at line number 27 and right click on it, go to debug as Java application, and let's see what happens. So yes, at line number 27, okay, it will stop, and you can just mouse over on names and you see that, okay, this is the, see, internal implementation. We will see that, okay, how exactly it is maintaining the data. See, this is the first pointer and the last pointer. Can you see that? If you open this particular first pointer, the value is Tom, and its next pointer is equal to null, right guys? And its previous pointer is also equal to null. And then you open this particular last pointer, that is item is equal to null, and its next pointer is pointing to null. It means you can see that, okay, Tom got added over here, right? In this particular first node, you can see that. Now, what exactly I'm going to do? I'm going to add Naveen now. So let's add Naveen, and let's see. Tom and Naveen both got added, and now you open this particular first pointer, see it carefully, how exactly it is implemented, and then see this. The first pointer, okay, item is equal to Tom, and next pointer is actually pointing to Naveen. Can you see that? It's next pointer. So this node, next pointer is pointing to Naveen. All right, guys, and the previous node is pointing to null because this is the head, and then again the last pointer that we have added is Naveen over here, and it's previously pointing to Tom over here. So it is creating a doubly linked list internally over here like that. Okay, so if you see this in the form of a basic diagram, how many nodes got created? 2 nodes, node number 1 and node number 2, like that, and it's actually divided into 3 parts. Let's see, I'm writing it like that, 1 and let's see 2, and this is the data. First data is Tom over here, and the second data I have added Naveen. That's why I really wanted to show you in the debug mode how exactly it is linked with each other. This is the next pointer, This is the next pointer for this guy, and this is the previous pointer of this guy, like that. So how exactly this next pointer is pointing to the previous pointer of this guy, and then previous pointer is actually pointing to this guy, like that. And this is the head of this particular linked list, and this is pointing to null over here, like that. This is null. Okay, this is the current situation right now. And how many values are there now? Two values, Tom and Naveen. So what is the current size? The current size is equal to 2 over here, like that. And that's why if you see in the debug mode, once again, see this exact design, try to understand with the diagram and try to see this internally how exactly it is happening. So let's, one second. Yeah, so let's a little bit open it like that. Now see the first node. Can you see the first node? First node is available on this particular object, and this is a memory address, and item is equal to Tom, and its next pointer is C pointing to Naveen. Can you see that next pointer is pointing to Naveen over here? And you open this particular first pointer, you can see item is equal to Tom, next pointer is pointing to Naveen, and its previous pointer is Naveen's previous pointer is pointing to Tom. So you can see that Naveen's previous pointer is equal to is equal to Tom. You can see previous pointer is equal to this. Perfect. And then its next pointer of Naveen's next pointer is pointing to null. You can see that Naveen's next pointer is pointing to null over here, and its previous pointer is pointing to Tom. Its previous pointer is pointing to Tom over here, right? Like that. And Tom's previous pointer is equal to Naveen, like that. So this is a doubly linked list will be created like that. Okay. So guys, this is how it works like that. So this is the equation for the first node, and this is equation for this last node, right? Like that. So this is how, guys, a linked list works in the form of it maintains a doubly linked list internally. The moment I add one more value, one more node will be created automatically, and then previous and next node will be connected with this particular node. Okay, so always keep this thing in your mind, and then let's proceed further. So let me terminate this particular debugger like that. Okay, now if I really want to print that system.out.println, I want to print this particular linked list. So let's see, the name of the linked list is names. And then if you run it, so let's see what exactly you're getting. So you're getting Tom and Naveen over here. Can you see that? See, Tom and Naveen, you can see it over here, right? The first value is Tom, second value is Naveen. So you can directly print over here like that. I write system.out.println. I simply say that, okay, hey, names dot get and pass the index. So it maintains the index. This is 0 and this is 1. So I simply write, let's see, on 0th index what exactly the value is available. So on 0th index you can see Tom is available. If you pass 1, you will get Naveen over here. The moment I pass a 2, the second index is not available. This is 0, this is 1. The moment you run it, you will start getting index out of bound exception. Can you see that? This particular error, index out of bound exception, you will get it. I hope it's visible, right? So you should not go beyond the index. Right now we have 0 and 1 only, so I cannot take 2 like that. So let's make it 1 only. Okay, now then we will see that simple basic stuff, that how to, let's see, iterate, right? That how to simple iterate. I want to print all the values from this particular array list. So how we'll do that? So very simple. I can simply use names dot iterator method you can apply. Okay, names dot iterator, which will give you what? Iterator will give you the iterator of a string. So I simply write iterator of a string over here, and let's see, the iterator name is it is equal to this, and this iterator you have to import from java.util package. Simple. And then what you can do is you can simply write one while loop, and you can simply write if it dot has next, then do what? Then keep printing the value. So I simply write it dot next over here, and then if you run it, it will print all the values. You can see Tom and Naveen. Perfect. So like this also you can simply do that. Right, now let's see, these are the two values that I have added, and let's add some more values. Let's see, I'm adding two more values. Let's see, I'm adding a Robbie and I'm adding Lisa over here. Four values I have added. Size will be 4 over here. And now what I'm gonna do that from this particular names dot see add method. This is the overloaded method. You can write, so you can see this on a particular index also you can add a particular value. So let's see, this is the zeroth guy, zero index, this is first index, this is second index, this is third index, right? So I simply say that on the fourth index, let's add some other guy. So let's see, I'm writing Steve over here, right? And then I'm going to print a names once again over here. So let's see what happens. So let me delete this particular drawing and let's run it again. So can you see that after adding these four guys are already there, and but on the fourth index I'm adding Steve, so Steve will be added over there. Right now I'll simple add names dot add, and then I simple say that okay, on the second index add a new value over here, right? So let's say I'm writing Ram. So on second index Robbie is available, so Robbie will be replaced by Ram. So let's see, quickly run it. Now I'm printing names once again, the entire list. Now you can see that okay, instead of Robbie, you can see that okay, Ram will be replaced, so Robbie will be shifted over here. That's why I told you, right? Sorry, by mistake, I told you that Robbie will be replaced. It means it will be shifted. I mean to say it will be shifted over here. Replace means it will be shifted over here, not exactly replaced. So Tom, Naveen, now between Naveen and Robbie, Ram will be added. That is what I told you initially in the beginning, that the shifting is very easy. The moment I Ram, Naveen's next node will be connected to Ram, and Ram next node will be connected to Robbie, like that. Okay, so it will create a linked list, W linked list like this. So Tom is connected to Naveen, Naveen is connected to Tom, Naveen is connected to Ram, and Ram is connected to Naveen, like that. So it will create a list over here like that, guys. Right? So initially between connection was like that between Naveen and Robbie. Now we have to add Ram. So that's why I told you, right? Ram, it will break the connection and then it will start pointing to Ram, and Ram will start pointing to Robbie, like that. So this is a really good thing that okay, in linked list insertion is very, very easy. That's why, like I told you in the beginning itself, that insertion and deletion can be easily implemented over here like that, just because of its a dynamicity, right? And it maintains the pointer of the previous node and the next node, right, guys? Okay, now let's see some more examples I have added. And what I'm going to do that okay, I'm going to create one more list over here. So let's see, let's create a new list. Let's say this is my users list, and in this particular users list I'm going to add a couple of users. Let's see, users.add, and now the new list I'm adding let's see Peter, and users.add, let's say I'm adding Trump, right? And then what I want that the new list that I have created, this new list I want to add it with the old list, this names list. So what I can do is simple write names.add all method is available, and you can pass the existing collection that you have already created, this particular users, you can add it, and then you print names list once again on the console, and let's see what happens. So you will see that okay, Peter and Trump will be added in the previous list. So you can use add all method in that case. Okay. So like this also you can simply do that. Now there are other various methods. Let's see. Now I'm right names dot add first method. Do you see that? Okay. So adding the element at the first position. So at the first position, let's see. I'm writing one more value that is okay. Let's see. Kamla. Okay. And let's see. And then I'm going to print this particular names once again, and you will see that okay, yeah, got added over here. And now I want to add at the last position. So what, there is one more method, names dot, I simply write names dot uh, add last, and at the last I want to add one value over here. So this time let's see, I'm writing Shivan. Okay, and then print the value of names once again, and let's run it. So you can see that okay, Kamala got added at the first position and Shivan got added at the last position. So this is again Insertion is very easy at the first position and the last position also you can do that. Okay. So other than that, guys, there are other various method, different ways you can remove also. So how to remove a value from this particular list? So let's see, right? Simple names dot remove method is there, and you can pass the index from the which index you want to remove. So let's say you want to remove the index from the remove the value from the second index. So let's see what happens. So I simple run it, and let's see. So you can see that okay, the 0, 1, and 2 Naveen is gone. Now Naveen is gone from this particular list, and Ram will be, and it will continue with Ram, Robbie, and like that. So that's why we can shrink the data whenever it's needed. So automatically the data, the size of the list of this particular list will be shrinked automatically, will be decreased automatically. Similarly, you can remove. If you see that okay, you can remove all, remove first, also you can do that, and remove last also you can do that. So if you removing, or if you really want to reuse the remove all method, so let's use remove all. Remove all means remove all the elements from this particular list. So okay, so we have to pass the collection. So let's see, I will pass users over here, and let's see, and then I'm writing system.out.println names. It means from the names list, remove all the elements which are coming from the users list. So let's see what happens. So now you can see that okay, from the users, Peter and Trump is gone. You can see that because from the users we have added Peter and Trump. Peter and Trump from gone from here. So you can use remove all. Okay, with other collections also you can do that. Same thing you can do remove first, remove last also you can do that. So let me quickly show you. I simple write remove remove first, and then I'll write names dot remove last, and let's run it. So let's see what happens. So now you can see that okay, again Kamala and Shivin is gone, and the final list we have with Tom, Ram, Robbie, Lisa, Steve, like that. Okay, so removing also it's pretty clear. And if you really want to remove everything, so you simply write names dot clear method is there, and then you print names once again. Then let's see what happens. See the blank list, you are getting it. Okay, so removing all the elements available in this particular list, you can simply do that. Right. Okay, now let's create one more list over here, and let me take this particular list once again from here only, and I simply write, let's see, this is my language list, and language as I'm writing, let's see, Java, I'm writing Python, here I'm writing Ruby and JavaScript, and the list name is lang dot add and dot size. Quickly I'll check it. You can see that okay, so size was 0 initially, and then if you run this particular size method once again after adding these 4 values, now you are getting 4 over here. Fine. Now the question is that I want to reverse a list. So how will you reverse this particular list? Reverse the linked list. How will you do that? So for reversing, it's very simple. I have to apply first of all an iterator. So with the help of iterator, you can do that iterator, and this iterator will give you what iterator of a string over here. So I'll store iterator of a string it. Let's see, itr is equal to this. Okay, and then on this particular itr, okay, what you have to do instead of iterator, guys, there is a reverse iterator is available, that is called a descending iterator. You can use it instead of normal iterator, and then you can use descending in the descending order. If you really want to print, you can simple write in a while loop, simple write itr dot has next, and then keep printing the value. I simple write itr dot next over here. Right, so it should be printed in the reverse order. So you have to write descending iterator. So you can see that okay, yeah, see it's printing JavaScript, Ruby, Python, and Java. So it will print all the elements in the reverse order. Simple. So these are the important methods, guys, are available. You can do the traversing. You can do the traversing in a normal way also, guys. So let's see, I want to do a traversing with the for each loop. How will you do that? I simply write a for what type of value we have. We have a string type of values. I print, I'll create any variable e, and what is the list name? My list name is language, and you simple write system.out.println print e over here. So what will happen? It will start printing from Java to JavaScript. You can see that. Okay, so with the typical simple for loop and for each loop also you can simple do that over here like that. Now one more thing, yeah, collections, collection sorting. So how will you sort this particular array list? So you can simple sort it with the help of collections class. There is a method, a sort method, and then let's pass language over here, and then I'm going to print this particular language list. So let's see, it is printing in this particular sorting order or not. So you can see that, okay, the J for Java, J for JavaScript, P for Python, and then Ruby. So it's coming in the sorted order like that. So you can put it in the sorting order also. Simple. So sorting, you can do that, and such sort of implementation, guys, you can add it. So these are the important methods. You can please check other methods and practice accordingly, and remember these basic notes. And in the previous session, in the previous video, I told you to how to implement a simple singly linked list. And in the upcoming chapters, I'll try to give some more example with respect to like how to create your own add method. See, right now, this add method is already available in this particular linked list class. But at the time of interview, they will ask you that, okay, hey, how will you create your own add method in this particular linked list? So create your own linked list class and create an add method. Create your own linked list class and create your own size method like that. So this will be the interview question, guys. These are very simple, basic interview questions, are evergreen questions people will ask you. Otherwise, you just need to create the linked list class and then start using these methods. That's not a big deal. Anyone can do that. But how exactly internally they are implemented and how will you create your own custom linked list? These are the important and tricky questions are there. Okay, so in all good companies, all big companies, people will ask these kind of questions in most of the product-based companies. So please prepare these questions. Very, very important, right? So there are different videos are available. They just cover the basic stuff like, yeah, these are the methods, how to print it, add, remove, all these methods. People are using existing method, but nobody is telling that, okay, how to create your own add method or custom methods. This is very important for interview point of view. Okay. Thank you so much, guys. Thanks for watching this particular video. I hope you got some idea about linked list, and I'll see you in the next video. Till then, take care and please subscribe to the channel and let me know if you have any issues. Thank you so much, guys.